Alright, we are going to factor trinomials. First, we're going to factor trinomials when a is 1, but if you have a trinomial ax squared plus bx plus c, then here are some useful tips on the signs. So not only when a is 1, you can use this for any type of trinomial when you're factoring. So if your trinomial resembles ax squared plus bx plus c or ax squared minus bx plus c, you're going to use the same signs. So if c is positive, then you use the same signs. You use the sign in front of b. So as we can see here, the sign in front of c is positive, and we use the sign in front of b. The sign in front of c is positive, and we use the sign in front of b. So if your trinomial resembles ax squared minus bx minus c or ax squared plus bx minus c, so you notice the c is negative. If the c is negative, you always have different signs, and the greater factor of c gets the sign in front of b. Now, that might seem a little confusing right now, but when we go over examples, that'll make sense that the greater factor of c gets the sign in front of b. So to sum this up, if c is positive, you're always going to have the same signs, and you're going to use the sign in front of b. If c is negative, you're always going to use different signs, and the sign in front of b goes to the greater factor of c. Now let's put this all to use for example 1. So I have 4 simple steps on how to factor when a is 1. Now you don't need to follow the 4 steps, but they're there just for guidelines. The more you practice, the easier it will become. So when a is 1, what that means is that there's nothing in front of this x squared. So when there's nothing in front of there, the first thing you want to do is determine the signs you're going to use. So to determine the signs we're going to use, let's take a look at c. C is positive. So since it's positive, we're going to have the same signs, and we're going to use the sign in front of c. So since our c is positive, we're going to have the same signs, and we're going to use the signs in front of b, which are negative. So we're going to have negative, negative. Now, the second step, always look for a GCF. That's greatest common factor. So if all of the numbers or all of the letters, if there's something in common with all 3 of those terms, you need to take it out before you start. In this case, there's nothing in common because we have x squared, 6x, and 8. None of those have anything in common. So our third step is to factor out a and c. So if we have our trinomial of x squared minus 6x plus 8, let's factor out a. Factoring out a means what times what gives us this. So for x squared, it's x times x. And for 8, it's 1 times 8 and 2 times 4. Nothing else. Now, we need to, since a is 1, we need to choose 2 factors of c that add or subtract to b. So if we're using the same signs, so if you have the same signs, you add 2 factors to add to b. So here we have 1 plus 8, that gives us 9. 2 plus 4 gives us 6. That's exactly what we need. So we're going to use 2 and 4. 2 and 4. And then since we have x and x, we're going to just go ahead and put x and x. And it's factored. So we can check our answer. Always check your answers if you're not confident about factoring, and I'm only going to do it this one time. So to check your answers, you multiply the outsides and the insides. So if we multiply the outsides and the insides, we have x times negative 4 is negative 4x, and then we have negative 2 times x is negative 2x, and when we add those together, we do get negative 6x, and that's exactly what b is. So we are all good to go. So we're going to move on to example 2 now. And now that we're moving on, we're going to simplify the directions so they're easier to remember. So we're going to factor n squared plus 6n plus 8. So very similar to example 1, but I want to show you when c is positive and we're going to use different signs, but you treat it the same way. So our first step is signs. Let's figure out what kind of signs we're going to use. So since we have a positive sign in front of c, we're going to use the sign in front of b of a plus. So we're going to have plus and plus. Our second step, is there a GCF? There is not a GCF, so let's move on to the third step. The third step, what we need to do is factor out a and c. So we're going to do that as factor AC. So if we factor a, that's n times n, and if we factor 8, that's 1 times 8 and 2 times 4. Now, since we're using the same signs, we need to add or subtract to get 6n, but since they're the same signs, we're going to add the two numbers. So what two numbers add up to 6? Well, that's 2 and 4. And then we're going to go ahead and just put n and n. And of course, check your answers if you want to. So let's move on to the next example, example 3. So we're going to factor 2n squared plus 6n minus 108. So we're going to continue. It might look different. We have something in front of n now, but you'll see when we go to step 2, something's going to happen. So it doesn't matter what is going on. The first step is always, let's check the signs. So since c is negative, we're going to use different signs. We're going to have a minus and a plus, or plus or minus. Remember, it's multiplication, so it doesn't matter what order they go in. Our second step is there a GCF? There is a GCF. They're all even. 2, 6, and 108 are all even, so we can go ahead and take a 2 out. So if we take a 2 out of 2n squared, we're left with n squared. If we take a 2 out of 6n, we're left with 3n. And if we take a 2 out of negative 108, we are left with negative 54. So you see how we took the GCF out? Because we absolutely have to. You cannot skip that step. Since we took it out, now there is nothing in front of this a. In front of the n squared. So we can go ahead and continue with how we usually factored. So our third step is to factor a and c. So to factor a, we have n times n, and to factor c, we have 1 times 54, 2 times 27, 3 times 18, and 6 times 9. You're going to get really good at knowing your factors of numbers at the end of all this. So since we're having different signs, it's opposite of when we have the same sign. So we're going to need to subtract two numbers to get to b. So since we are using different signs, we subtract two factors from c to get b. So let's take a look at our factors. We need to get to 3n. So what two numbers, if we subtract them, give us 3? Well, 9 and 6 will give us 3. So the greater factor of c gets the sign in front of b. So we're going to go ahead and put n and n. and the greater factor of C. So we have 9 and 6. 9 is the greater factor. So the greater factor gets the sign in front of B. The sign in front of B is positive, so 9 goes to positive, and then 6 goes to negative. And don't forget to put that 2 back down there with there that you took out already. So we're not going to spend too much time when A is 1. I know most of my students and people I know who factor are very proficient at that. So we're going to move on factoring trinomials when A is not 1. That's when it gets a little hard. So when we factor trinomials when A is 1, I created a method a long time ago that I still use to this day, and I teach it to my students. And of course, I'm going to call it the Milton method. Whether or not other people are doing it out there, I don't know. I haven't seen it. So I'm going to take the credit for it. And if not, please let me know. So the Milton method. There are 6 steps. The steps do get easier the more you do it, and we have plenty of examples to go over. So our first step, just like before, we want to determine the signs. So after we determine the signs, just like before, we want to look for a greatest common factor. Our third step doesn't change. We want to factor A and C. Now this is where it gets a little different. Our fourth step, we want to draw an X, a pretty big X, and you'll see how big. So a sub part of step 4, so after we draw an X, we want to put one set of factors from A, top and bottom, and we want to put one set of factors from B, left to right. Our fifth step, we're going to pick away and multiply. And after we pick away and multiply, our goal is when from step 5, the product we get will add or subtract to B. And our last step, is whichever way not multiplied are your factors, and then we're going to determine which sign goes where. Now, these directions might not make any sense. That's fine. We need to go over some examples, and then they will start making sense, and I will simplify them along the way. So, example 4. So, I'm going to simplify the directions now. Our first step, we want to determine the signs. So let's determine the signs. Since we have a negative in front of C, we're going to use different signs. So we're going to have minus, plus. Our second step, Is there a GCF? Nope, there's no GCF. So let's move on. Our third step, factor A and C. So let's factor A. We have 3p times p. That gives us 3p squared. And for 5, we have 1 times 5. Our fourth step, draw an x. And then we're going to put factors of A top and bottom. Let me write that bigger. We're going to put factors of A top and bottom, and one set of factors from C left to right. So let's draw our x. We're going to select one set of factors from each A and C. So for A, we only have 3p times p. There's no other set of factors. So we're going to pick that, 3p and p. And for C, we only have one set of factors, 1 and 5. Now we're going to pick away and multiply. And our goal after we pick away and multiply is to get negative 2p. So just like before when A was 1, we're going to subtract to get to our answer because they're different signs. If they were the same sign, we would add to get to the answer. But you don't necessarily need to remember that when it comes to this. So we're going to pick away and multiply. I'm just coincidentally, I'm going to go left. You can go right first. It doesn't matter which way you go first. Just pick away. So I'm going to go left and multiply. So we have 3p times 1 is 3p. And p times 5 is 5p. Now, is there anything we can do with 3p and 5p to get negative 2p? Well, yes, there is. We can make the 3 positive and the 5 negative, because if we have positive 3p positive 3p minus 5p, that equals negative 2p. So the last part of, so that's steps 5. Is to pick away and multiply. And our last step is to determine which signs go to what factors and which factors are we working with. So what that means is, how did we get the positive 3p? What did we multiply? Well, we multiplied 3p and 1. So the 1 must be positive. And how did we get negative 5p? Well, we multiplied p times 5. So the 5 must be negative. In whichever way we didn't go, so the opposite way of our arrows, I draw little dashes, are our factors. So we have 3p minus 5, wrong color, 3p minus 5, and p plus 1. And that's our answer. So let's move on. Let's do another example. All right, the more you see, the better. So example 5. So example 5, we're going to factor, of course, 2n squared plus 3n minus 9. So our first step, we want to pick the signs. So we have a negative in front of C, so we're going to have two different signs. Our second step, is there a GCF? Nope, there is not. So let's move on to our third step. We're going to factor A and C. So if we factor A, it's 2n times n. If we factor C, we have 1 times 9 and 3 times 3. Our fourth step, we want to draw an X. Oop, wrong color. So we draw an X and we want to put factors of A top and bottom and factors of C left and right. So factors of A, we only have one set to pick from. We have 2n and n, so 2n, n. And for C, we have two factors to pick from. We have 1 times 9 and 3 times 3. Now, there's always a helpful hint when you're choosing your factors in which to multiply by. You want to start you want to start with your lowest factors. So meaning like the smallest numbers. So 3 times 3 is smaller than 1 times 9. So we're going to use 3 and 3. And we're going to pick away and multiply. So I'm going to go right this time. Doesn't matter which way you go. Just pick away and determine, does it work for us. And our goal is to get positive 3n. So if we go to the right, we have 2n times 3 gives us 6n, and n times 3 gives us 3n. So is there anything we can do here to get positive 3n? Well, yes, there is. If we make 6 positive and 3 negative, we get positive 3n. So how did we get this positive 6n? Well, we multiplied 2n times 3. So then that 3 must be positive. And we multiplied to get negative 3n by n times 3. So this 3 must be negative. And whichever way we did not go are our factors. So we have n plus 3 and 2n minus 3. And we're done. Alright, so I am chock full of examples. We have several more to go to. Example 6. Alright, so I'm going to stop writing the steps and I'll just number the steps what we're doing. So our first step, we want to determine the signs. So we have the same sign because we have a positive in front of C, and we're going to use our negative because that's the sign in front of B. Our second step, is there a GCF? Nope. So let's move on. Our third step is to factor A and C. So we have 3n times n, 1 times 4, and 2 times 2. Our fourth step is to draw an x. And we're going to put factors of A top and bottom and factors of C left and right. So for A, we only have one set to pick from. We have 3n and n. For C, we have 1 times 4 and 2 times 2. But remember, you want to start with the smallest numbers. So we're going to pick 2 and 2. Now we're going to choose a way and multiply. So as you notice, when we have two numbers right here that are across from each other that are the same, it doesn't matter which way you multiply. So if across from each other, so if C are the same or if A is the same, it doesn't matter which way you multiply. Only when two of them are the same. So let's just go left. So our goal is to get negative 8n, and since we're using the same signs, we're going to add two numbers to get negative 8n. So we have 6n and 2n. So 3n times 2 is 6n. n times 2 is 2n, and we have to get negative 8n, so they both have to be negative. So how did we get this negative 6n? We multiplied 3n times 2, so that must be negative. Make that neater. Oops. So it has to be negative. And then how did we get negative 2n? Well, we multiplied n times 2, so this 2 must be negative. And whichever way we didn't go are our factors. So we have n minus 2 and 3n minus 2. I hope this is getting a little easier for you. But if not, I have more examples to go through. So, example 7. In total, we have 9 examples, so we're almost done. Example 7. I hope by the end of this, you're tired of writing factor, because I am. So we're going to factor 15x squared minus 27x minus 6. So our first step we want to determine the signs. So since c is negative, we're going to have different signs, minus and plus. Our second step, is there a GCF? Yes, 15, 27, and 6 all have 3 in common. So let's take a 3 out. If we take a 3 out of 15, we're left with 5x squared. If we take a 3 out of 27, we're left with 9x. And if we take a 3 out of 6, we're left with 2. You absolutely have to do step 2. You have to take the GCF out if there is one, because if not, you will not get the right answer. So after we figure out is there a GCF, our third step is to factor out a and c. So we have 5x times x and 2 times 1. Our fourth step, we're going to draw an x and put one set of factors from each, top and bottom, left and right. So luckily we only have one set to pick from, so we have 5x and x and 2 and 1. And since they're different signs, we need to subtract to negative 9x. So I'm going to go right. Let's say that you haven't picked up kind of how to do this in your head. Let's go right. So if we go right, we have 5x times 1 is 5x, and we have x times 2 is 2x. So there's nothing we can do there, because since they're different signs, we need to subtract. And if we subtract, we get 3x. There's nothing we can do to get negative 9x. So what that's saying is we should try the other way. So if at first one way of multiplying doesn't work, try the other way. So we're going to try the other way. So to try the other way, we're going to still use the same factors of 5x and x, 2 and 1, and we went right the first time, so let's go left. So our goal, we need to get negative 9x, so when we multiply, we have 5x times 2 is 10x, and x times 1 is 1x, and we can get negative 9x if the 10 is negative and the 1 is positive. So how did we get the negative 10x? Well, we multiplied 5x times 2, so the 2 needs to be negative. And then how did we get positive 1x? Well, we multiplied x plus 1, so that must be positive. Now, whichever way we did not go are our factors. So we have x minus 2 and 5x plus 1. And don't forget to bring that 3 down, because I always do. So don't forget that. Alright, moving on. Example 8, only 2 more to go. Although, truly, I can do this all day. I love factoring. Nope, I said factoring, so I got excited about it and wrote it. So factor. We're going to factor 2x squared plus 7x minus 7. So, our first step, we want to determine the signs. Oop, wrong color. So let's determine the signs. Well, c is negative, so that means we're going to have different signs. Our second step, is there a GCF? Nope, they're all prime, so there's no GCF. Our third step is to factor a and c. So for a, we have 2x times x. C, we have 7 times 1. Our fourth step, we're going to draw an x. We have 2x. Oop, want that to be colored. We have 2. There we go. We have 2x and x, 7 and 1. And since we're using different signs, right, we need to subtract to get positive 7x. So let's go left. We get 2x times 7 is 14x. And x times 1 is x. We cannot subtract that to get 7x, so that doesn't work. Let's try the other way. So we have our 2x and x, 7 and 1. We went left the first time, so let's go right. We need to get to 7x. So we have 2x times 1 is 2x. X times 7 is 7x. We cannot subtract those to get 7x. So, are there any more factors to choose from? There are not. We used all the factors we could. So if you use all the factors that you can and you use all the ways to multiply and nothing can work, it's called a prime trinomial and it cannot be factored. So it's already in simplest form. So if you try every factor and multiply both ways, but nothing can work, the trinomial is prime, and it's unfactorable. Alright, last example. Example 9. So, we're going to factor 6x squared plus 37x plus 6. So, our first step, we want to determine the signs. Since our c is positive, we're going to use the same signs, and we're going to use the sign in front of b, plus and plus. Our second step, is there a GCF? Nope, there is not, so let's move on. Our third step is to factor a and c. So we have 6x times x, 2x times 3x, and c, we have 1 times 6, and 2 times 3. So we're going to pick the smallest numbers first, and then work our way up if we have to. So let's draw our x for step 4. We're going to put one set of factors from each, top and bottom, left and right. So we have 2x and 3x, and then we're going to have 2 and 3. So let's pick away and multiply. Let's go left. So if we go left, our goal is to get 37x. If we go left, we have 2x and 2 is 4x, 3x and 6 is 9x. There's nothing we can do to get 37. So let's try the other way. Now, if we try the other way, so we went left first. Let's go right this time. And we need to get to positive 37x. So we get 6x and 6x. That does not equal it, so we need to try different factors, because obviously these two are not working together. So let's stay with 2x and 3x and move on to 1 and 6. You don't want to move up in the x's until you tried all the factors of c first. So the c is what you're going to change first, and then move your way to a if you have to. So let's keep going. So we're going to have 2x and 3x. And now we're going to use 1 and 6. We still need to get to our positive 37x. So let's go right. If we go right, we get 12x and 3x. There's nothing we can do. Doesn't give us 37x. So how about if we erase this and go left? If we go left, we get 2x and 18x. Oh, we're getting close, but that's only 20x. So what that tells us is 2x and 3x is not a factor. So since those aren't factors, let's move our way to the a side and change it from 3x and 2x to 6x and 1x. So we have 2x. Oh, nope, we're not doing that anymore. My bad. We have 6x and x, and then we're going to use 2 and 3. So if we go right, I want a different color, I don't want that one. So if we go right, we get 18x and 2x. Again, that does not give us 37x. So how about we change it and go left. So if we go left, we get 12x and 3x. That doesn't give us it. So we can't use 2 and 3. Let's try 1 and 6. So we have 6x. Let me get a different color. We have 6x and x. 2 and 3 doesn't work. So let's use 1 and 6. You might be able to see it. We can go right. We want to get to positive 37x. So we have 6x times 6 is 36x. X times 1 is x. And if both of those are positive, we are good to go. So how did we get positive 36x? Well, we multiplied 6x times 6, so that needs to be positive. And how did we get positive x? Well, we multiplied x times 1, so this must be positive. And whichever way we didn't go are our factors. So we have x plus 6 and 6x plus 1. And there we go. So if you have any questions, leave them in the comments, or if you're my student, ask me in class either before or after, come in my office hours. But if not, I really hope you enjoyed this and learned something, and pass it along if you like it.